Across the long backbone of South America lies a quiet landscape shaped by wind, stone, and time. The Andes rise in steady lines, holding valleys where early cultures lived, built, and vanished. But beneath these high plains, beneath the cold lakes and silent peaks, signs appear of something far older than the civilizations we know. Scattered stones, long corridors, smooth caverns, and deep voids show patterns that do not match natural forces. They form straight paths across mountains, connect hollow spaces inside peaks, and rest under layers of soil untouched for thousands of years. The measurements repeat the same angles, the same shapes, the same quiet precision. It suggests a hidden world built in an age we do not yet understand. In this documentary, we follow these traces calmly, step by step, into the network beneath the Andes, where each discovery adds a small, steady piece to a much older story still waiting to be seen. Hidden foundations beneath the stone. Beneath the long shadow of the Andes, there are places where the ground feels older than the mountains around it. In these quiet valleys, researchers have walked over flat stones that do not match the rock beneath them. They have found walls made of andesite blocks shaped with angles too sharp for natural weathering. These stones appear in areas with no written history, and yet they show a level of skill that seems to belong to an age not recorded in any known timeline. Many of these sites lie between Peru, Bolivia, and northern Chile, where narrow paths lead toward high plateaus. The French archaeologist Henri Laval wrote in 1932 that the earth here hides more than it reveals, a line that would be quoted again decades later by explorers who found structures that did not fit any local pattern. The region around Lake Titicaca is often mentioned in these discussions. In 1956, a survey crew found a line of cut blocks buried under a meter of soil near a hillside called Cerro Umauta. The rocks were shaped like parts of a collapsed stairway, though the steps were wider than those from the Tiwanaku period. Carbon tests on nearby organic debris suggested a date older than 3000 BCE, raising questions because the known cultures of the Andes at that time were still in small village stages. A geologist named Arturo Medina reported that the cuts on the blocks showed uniform pressure marks, which suggested the use of tools harder than the stone itself. No metal fragments were found in the soil above or around them. As light moves across these high plains, the stones reveal marks that seem too straight to be accidents. Some are aligned toward distant peaks. Others are part of lines that stretch longer than any visible structure. In 1974, a researcher named Maria Quispe walked nearly 8 kilometers along one of these alignments, near the village of Icoca. She wrote in her field journal that the stones form a steady path, not on the surface, but under it. Her notes describe how, in some places, the soil had eroded just enough to expose the tops of blocks arranged in a line. When she dug deeper, she found more stones beneath them, forming what looked like a layered walkway. Farther south, near the Chilean border, there are small caves with unusually smooth floors. These chambers do not show torch soot, but they carry signs of water channels carved with consistent slopes. In 1991, a team studying local aquifers in Tarapacá province entered one of these caves. They noticed that the floor sloped exactly 1 degree downward for more than 30 meters. Light from their lamps showed faint grooves on the walls, suggesting that someone had shaped the stone with long, slow strokes. There were no signs of habitation, no pottery, and no animal remains. The cave appeared to be part of a system created to move water quietly through the earth. The plateau known as Pampa del Sol holds another puzzle. Here, the ground is flat, covered with thin yellow grass. Beneath the surface, however, sonar mapping in 2004 revealed a grid of hollow sections. These shapes measured almost equal distances from one another. The Spanish engineer Carlos Henao, who led the study, stated that the forms resemble subterranean chambers, possibly connected. His team drilled a small core into one of the anomalies. The sample brought up a mix of fine dust and tiny fragments of smoothed stone. The dust did not match the surrounding soil. It was lighter and did not clump when exposed to moisture. People living in the Andes have long told stories about structures buried deep below the mountains. These accounts often mention corridors where the air moves without wind and rooms lit by stones that hold daylight. In 1968, anthropologist Elvira Ramos recorded an interview with an Aymara elder who spoke of the builders beneath, a group he described as neither gods nor ordinary humans. According to his account, they worked in silence, carving the dark. While these oral traditions are not treated as historical evidence, they offer a glimpse into how ancient people understood the hidden layers of their land. In the village of Pucará, an unusual object was found in 1979. It was a cylindrical stone tube, carved with a spiral that ran from top to bottom. It measured just over 30 centimeters tall and was polished inside and out. When researchers looked at it under magnification, they saw thin, parallel striations that suggested it had been finished using a rotating motion. The object did not match any known ceremonial or practical tool from the region. A local farmer who observed the excavation mentioned that similar tubes had been found near the old mouth of the hill. He said these items were usually left untouched because villagers believed they belonged to those who lived before the sun marked the year. High above the valleys, near peaks that rise beyond 5,000 meters, scattered stones appear in places where building is nearly impossible. At Cerro Pucarani, climbers in 2007 found a set of flat blocks forming a rectangle. The structure measured roughly 4 meters across. The stones were not heavy, but they had been shaped into smooth, even surfaces. The cold and wind of the region make it unlikely that long-term settlements existed there. The climbers believed the platform might have served as a marker rather than a dwelling. Its exact alignment, when measured later, pointed directly toward a lower ridge where another isolated stone stood. The idea of a hidden civilization beneath the Andes gained attention in 2011 when a team conducting deep ground-penetrating radar studies near Huaylas detected a void 30 meters below the surface. This cavity measured over 200 meters in length. The signal showed smooth edges on one side, as if cut by tools. Excavation was not possible due to unstable terrain, so no direct access was attempted. However, a second void appeared about half a kilometer away, shaped like a curved tunnel. These findings led some researchers to wonder if natural processes alone could shape such consistent forms. In 2015, a small expedition entered a crack near Quebrada Honda after a landslide exposed part of a chamber. Inside, they found stone blocks arranged in a pattern that suggested a roof had collapsed long ago. The floor was covered in fine powder, similar to the samples taken from Pampa del Sol. One of the explorers reported seeing small circular impressions on one of the blocks. These impressions, arranged in a ring, seemed to be placed with deliberate spacing. The team recorded measurements, but left the site untouched because the chamber walls showed signs of stress. During a quiet season in 2018, a group of researchers spent 3 months documenting faint lines near the base of the Apolobamba range. They used a simple method, walking slowly, recording every stone that seemed shaped or moved. At the end of the study, they had mapped over 40 kilometers of alignments. Some lines led toward mountains, others disappeared under slopes. The researchers noted that the stones often sat at equal distances from one another, forming patterns not found in natural rockfalls. Each year reveals more evidence of something long hidden. The soil continues to shift. Ice melts in the high peaks, landslides expose new surfaces. Beneath the Andes, the signs remain steady, waiting for interpretation. Corridors beneath the highlands. Across the spine of the Andes, there are long stretches of ground where the soil appears ordinary on the surface, but carries subtle dips that align with one another over great distances. These dips are often no more than a few centimeters deep, yet early explorers noticed that they follow directions that do not match natural drainage or animal trails. In 1894, the German surveyor Wilhelm Stadler mapped several of these lines near the town of Ayaviri. His notes mentioned a gentle fall in the earth, uniform in way and width, running for almost 2 kilometers. When villagers were asked about it, they called the line the old road beneath, suggesting that whoever built it worked underground rather than on open land. In 1921, a mining crew near Huancavelica broke into a hollow space while drilling through soft sediment. The chamber they entered had smooth walls that curved upward, meeting at a clean point overhead. The miners described it as a corridor, though the air inside felt heavy and still. The passage extended in both directions, but narrowed after several meters. The walls showed faint marks that resembled long tool strokes. No artifacts were found. The mining company sealed the holes soon after, fearing collapse, but a few workers wrote that the corridor seemed older than the rock around it, an observation that puzzled geologists at the time. Farther south, in 1959, an expedition led by the Peruvian researcher Luis Barranecchia documented a series of shallow sinkholes near the Apurimac River. When measured, these depressions aligned almost perfectly with a distant ridge. Barranecchia lowered a lamp into the largest sinkhole and saw a flat surface made of fitted stones. The stones were arranged in a pattern that created a long, straight path. He recorded that the floor was too even to be natural. From the lamp's light, he noticed parallel grooves along the edges of the stones. These grooves showed uniform spacing, which suggested repeated cutting or smoothing. Reports of underground passages continued into the late 20th century. In 1973, a group of local farmers near Chivay discovered a narrow crack in the hillside after heavy rainfall. When they climbed inside, they found themselves in a small passage about a meter wide. It ran straight for at least 20 meters before ending in a collapse. The walls were made of volcanic rock, but the inner surfaces were polished to a dull shine. One of the farmers, Mateo Huanca, later told a visiting researcher that the corridor did not feel like a cave because the walls were too straight, as if shaped by someone who knew exactly how much stone to remove. A Chilean hydrology team, working in 1988, found something similar near the Lauca River. While checking underground water flow, they detected a long cavity beneath a barren slope. The cavity formed an almost perfect rectangle when traced by instruments. When they drilled a thin borehole into it, the drill struck stone that did not match the surrounding geology. The core sample contained a mixture of crushed andesite and a type of dust not found elsewhere in the area. The dust had a smooth texture, almost like ground glass, which puzzled the team. One member, engineer Jorge Salvatierra, wrote that the shape and composition suggest deliberate workmanship rather than erosion. In 2002, satellite imagery revealed faint, straight lines running across areas with no known structures. These lines were too narrow to be roads and too long to be natural fissures. A study by Eduardo Cardenas compared these features with older maps and found that some of them matched corridors documented in early missionary accounts. A Jesuit manuscript from 1648 mentioned paths below ground where the air travels slowly, describing them as old even at that time. The manuscript did not specify who built them, only noting that they were used by local groups during long travels. The corridors are not always straight. Some follow curved paths that maintain consistent radius measurements. Near the Bolivian village of Charania, a collapsed opening revealed part of a circular passage that looped back toward itself. It measured less than a meter high and required crawling to enter. Researchers in 2014 noted that the curve held the same angle for its entire arc. They examined the stone along the inner wall and found chisel-like marks spaced every few centimeters. The pattern suggested a slow, controlled shaping process rather than quick cutting. There are locations where the corridors widen into chambers. In 2017, a landslide near Kurawasi exposed part of a large underground room. The walls were made of fitted stones with straight joints. When researchers measured it, the room formed a rectangular space 10 meters long. Inside, there were no objects, but the floor carried a slight slope toward one corner. Light from handheld lamps revealed a shallow channel carved into the floor. This channel led into a blocked opening that appeared to connect to another passage. The channel's angle was precise enough to suggest water movement. Local stories often describe these corridors as places where sound travels strangely. In 1965, anthropologist Teodoro Salinas interviewed residents of a small settlement near Sikwani. One elder told him that a voice spoken at one end can be heard at the next hill, referring to a corridor believed to run beneath the ground. Although this cannot be confirmed, the idea reflects a long-standing belief that the passages were built with careful acoustics. Some researchers have suggested that long, narrow stone tunnels could carry sound farther than expected, especially if the walls were smooth. The deepest known void linked to the corridor network was recorded in 2019 during a seismic survey near Kajetambo. Instruments detected a narrow space running almost 60 meters below the surface. It extended straight for over 400 meters. The signal showed flat edges on both sides, which is unusual for natural cracks. Attempts to locate an entrance above ground were unsuccessful, but the formation matched earlier reports of long underground routes. The seismic team described the void as stable but clearly shaped, a phrase that raised questions about how ancient builders might have created such a space. Another interesting discovery came from acoustic tests performed in 2021 near the village of Kakawasi. Researchers tapped the ground with a metal rod along a slope. At certain points, the sound produced a hollow echo. Mapping these echoes formed a line that extended more than a kilometer. This hollow line matched a set of stones arranged on the surface in a pattern that looked deliberate. The stones were spaced evenly, and each one was narrower at the top, as if shaped for marking. Many of these findings appear isolated, yet the patterns suggest a network that once extended beneath a large part of the Andes. These corridors may have carried water, served ritual purposes, or supported communication. Their true function remains unknown, but their consistency across different regions points to a shared architectural understanding. When explorers shine their lamps into these passageways, the light reveals old marks, quiet channels, and long pathways carved with patience. The subterranean chambers of Lake Titicaca. Around Lake Titicaca, the ground holds layers that have shifted for thousands of years, covering traces of structures that do not appear on any official archaeological record. The lake basin, shared by Peru and Bolivia, sits at an elevation of more than 3,800 meters. The air is thin, the light is sharp, and the soil carries fragments of pottery from many eras. But beneath these surface remains, explorers have found signs of chambers shaped in stone, arranged in ways that do not match the known architectural styles of Tiwanaku, Pucara, or any early Andean culture. The earliest mention of these hidden rooms appears in an 1879 travel report by the English explorer Richard Sessions. While crossing the southern shore, he recorded an unusual depression near the village of Chua. When he tapped the ground with his walking stick, the sound echoed briefly. He dug into the soil and uncovered part of a stone block. The block showed a smooth, angled cut that curved downward. Sessions believed he had found the roof of a chamber, but lacked the tools to excavate further. He wrote that the hollow beneath gives the sense of great age, a phrase that was dismissed at the time because no known civilization in the region was believed to have built underground. In 1937, a group of Bolivian surveyors mapping farmland near Acacachi noticed a circular sinkhole. The farmers said it had opened after a mild earthquake. Inside the hole, the surveyors saw the top of a chamber made of fitted stones. Each block had been shaped into trapezoidal forms, similar to later Inca work, but the stones were different in texture and weight. When touched, they produced a muted sound rather than a sharp ring. The chamber measured 3 meters across and contained a pillar-like structure in the center. No inscriptions were visible. The roof was made of a single massive slab with a smooth underside. Around 1951, when drought lowered the lake's water level, fishermen near the town of Tarraco reported seeing rectangular outlines beneath the shallow waters. When divers entered the lake to investigate, they found submerged stone walls forming what appeared to be a grid. The divers described one area as a sunken courtyard with an open doorway leading to a sloped passage. The passage was filled with sediment, but its angle suggested it might once have led to a chamber deeper below the lake bed. Samples taken from the walls showed a combination of andesite and a softer volcanic stone that had fused together under heat. This method of fusion has no known precedent in Andean building traditions. In 1964, the archaeologist Efrain Lurin conducted a systematic survey of the peninsula of Capachica. His team found several flat surfaces hidden beneath layers of soil. These surfaces formed the tops of chambers that were rectangular in shape. One chamber near the village of Lachon had a roof stone with a precise circular hole carved into it. The hole was perfectly smooth and measured 10 centimeters across. Lurin suggested it might have been used for observing the sky from below ground. Locals, however, claimed the hole was for breath, a phrase repeated in several nearby communities. Another site came to attention in 1978 when a heavy storm caused a hillside collapse near Huatajata. The exposed slope revealed an entrance sealed by stones arranged in a hexagonal pattern. When researchers cleared the area, they discovered a chamber beyond the entrance. The chamber was nearly 6 meters long, with walls made of large blocks arranged in alternating layers of wide and narrow stones. This technique does not match any known Andean style. The chamber floor was covered in fine powder, similar to samples taken from older underground sites across the Andes. A carved stone basin sat in one corner. The basin had small channels that seemed designed to carry liquid in controlled lines. One of the most detailed studies occurred in 1999 when a joint Peruvian-Bolivian team used ground-penetrating radar around the lake's northern shore. The scans revealed at least 14 voids arranged in a rough circle. Each void measured between 3 and 5 meters in diameter. Several were connected by narrow channels. The structures lay 10 to 15 meters below the surface. When the team drilled small access cores, they found finely polished stone fragments as well as tiny beads of a metallic substance. The beads were too small to identify visually, and their exact composition remains uncertain. The radar images showed straight edges on the voids, suggesting artificial construction. In 2007, a submerged chamber became accessible after a drop in lake level following a dry season. Divers entered through a narrow slit in the rock and found a room with smooth walls that formed a perfect rectangle. The walls were made of stones placed so tightly that no gaps were visible, even under close inspection. The room contained a single-stepped platform with 3 levels. The steps were unusually steep, more vertical than horizontal, which made climbing difficult. The stone surfaces showed no carvings, but faint lines of discoloration hinted at water flow or long-standing moisture. In 2013, researchers studying seismic activity reported unexpected acoustic reflections beneath the lake's eastern edge. These reflections suggested layered chambers stacked one above another. The deepest chamber appeared to lie almost 40 meters below the lake bed. The layered arrangement resembled storage rooms or controlled environments rather than natural caves. Attempts to drill deeper were abandoned because the equipment could not maintain stability in soft sediment. The reflections, however, remain part of ongoing studies. Local oral histories often mention houses of the dark water, described as places where early ancestors hid from the sun. An Aymara elder, interviewed in 1985, explained that these chambers were built before the sky changed, though he did not define what that meant. According to his account, some chambers were used for storing heavy stones too important to leave on open ground. When asked why the stones mattered, he only said they were old when the lake was young. In 2020, new sonar scans detected a long, narrow space near the Kasani Peninsula. The space measured nearly 80 meters in length. Its walls formed straight lines, unlike natural underwater formations. When divers reached the site, they found a sealed entrance made of interlocking blocks. These blocks were shaped in a way that allowed them to support each other without mortar. One diver reported feeling a cold, steady draft coming through the cracks, suggesting an open space behind the sealed wall. With every new scan, collapse, or drought, more chambers appear around Lake Titicaca. Each one follows patterns of precision, alignment, and material choice that add to the growing body of signs. The chambers remain silent, but their walls still hold shapes carved by tools whose makers have not yet been identified. The builders of the silent stone. Across the high plateaus and deep valleys of the Andes, the question of who carved the hidden chambers and narrow corridors has followed every excavation, every survey note, and every new scan. The stones themselves carry marks that suggest method, repetition, and deliberate planning. Yet no known culture from the region's early periods fits the level of precision observed in the deeper structures. This absence has led researchers to search for faint clues left behind by the earliest people who walked these mountains long before recorded history began. In 1934, the Bolivian archaeologist Mateo Anchieta examined a set of stone fragments near the Rio de Desaguadero. These fragments were shaped like wedges, with edges so straight that they appeared to have been cut using a technique unfamiliar to him. Anchieta believed the fragments came from tools rather than walls. He wrote that each piece showed a symmetry not seen in the common implements of the early lake cultures. The material itself was unusual. It resembled andesite, yet its grain structure was smoother than local varieties. Some fragments displayed parallel lines, as if they had been pressed or rubbed against a consistently moving surface. Further north, near the Peruvian town of Lampa, a farmer uncovered a small stone object in 1947 while preparing a field. The object was shaped like a thin disc with a raised central ridge. When held up to the light, it revealed faint striations arranged in concentric circles. The disc did not match any known artifact from early Andean societies. A visiting geologist suggested it might have been part of a measuring device or a tool used in smoothing stone. He reported that the disc emitted a slight resonance when tapped, a quality not typically found in ceremonial pieces. By 1972, when the first systematic surveys of underground features began, researchers started noticing links between the corridors, chambers, and tools found in scattered areas. The Peruvian engineer Carlos Villegas examined several tool marks inside a collapsed passage near Ayata. He observed that the cuts followed patterns consistent with repetitive downward pressure. The marks suggested that the builders used a tool capable of compressing stone rather than chipping it. Villegas noted that the texture around the cut lines appeared melted rather than fractured, a detail that would remain unexplained for decades. In 1989, excavators near the Bolivian community of Santiago de Machaca encountered a deposit of tiny polished stones buried under layers of soil. These stones were shaped like elongated droplets, each one identical in size and weight. When examined under magnification, the stones showed smooth surfaces with no sign of hand carving. Some researchers proposed they could have been components of a larger tool or part of a mechanism used for leveling and measurement. A physicist on the team, Dr. Raúl Cortés, noted that their uniformity exceeded what could be achieved by simple grinding methods known from ancient Andean cultures. One of the most debated finds emerged in 2005 during a controlled excavation west of Copacabana. Archaeologists uncovered several flat stone panels arranged in a row beneath a collapsed ridge. These panels displayed a precise pattern of shallow indentations. When measured, the indentations aligned perfectly with the angles of nearby corridor walls. The excavators suggested the panels might have been guide stones used to plan or align underground structures. If true, this would imply a level of architectural foresight far earlier than any known Andean civilization. Oral histories from communities around the lake and mountains add another layer to the mystery. Many stories describe a group known simply as those beneath. These accounts do not present them as supernatural beings, but as people who preferred to build underground rather than above the surface. An Aymara elder, interviewed in 1976, described them as quiet ones who shaped the dark. He claimed they passed knowledge through shadows on stone, though he did not clarify what that meant. Explorers in the early 20th century also recorded unusual footprints preserved in hardened sediment near Puno. In 1911, the Argentinian naturalist Emilio Cordova photographed a set of tracks that appeared unusually narrow and evenly spaced. The prints were too small to be from pack animals, and they lacked the width typical of human footprints from the region. Cordova wrote that the stride is consistent, the depth is uniform, and the direction does not waver. Such traits resemble measured walking rather than casual movement. Some researchers believe these builders belonged to small groups that lived in the Andes long before agriculture spread across the region. This idea was strengthened in 2018 when deep soil cores taken near the Cordillera Apolobamba revealed layers of ash containing microscopic fragments of worked stone. The fragments displayed tiny curls at the edges, suggesting they were shaved or sliced from a harder material. The ash layer dated to more than 7,000 years ago, predating any known stoneworking culture in the area by millennia. Occasionally, fragments of unusual composition appear near deep cavities. In 2021, a team surveying near the town of Ananea found a piece of stone with an embedded metallic streak. The streak was thin and straight, running the length of the fragment. Tests showed the metal did not correspond to known copper or tin sources used by ancient Andean groups. The metal was brittle and broke easily, yet its placement in the stone suggested it had been part of a larger structure or tool. The fragment was too small to identify its purpose. Another discovery occurred in 2022, when researchers explored a narrow fissure near the Desaguadero River. Inside, they found a smooth stone column only 20 centimeters tall. The column tapered downward and ended in a flat circular base. Its surface carried shallow grooves spiraling from top to bottom. The grooves were so evenly spaced that they appeared machined. The team found no other objects nearby, but the column's precision deepened the question of who the builders were and what tools they used. The idea of a lost group with advanced stone manipulation abilities continues to circulate among researchers who examine these finds closely. The architecture beneath the Andes suggests knowledge of alignment, pressure distribution, and controlled carving. The builders may have lived in small, scattered communities, leaving limited surface evidence. Their work, however, remains beneath the soil, in the quiet corridors and stone chambers that still hold the marks of hands unknown. When the mountains shifted, across the long backbone of the Andes, the earth has moved in ways both slow and sudden. These movements have buried chambers, exposed corridors, tilted platforms, and fractured entire slopes. Every shift has added or removed clues about the structures hidden below. Geological records from the region show that many of the deepest features now studied by researchers were once closer to the surface before pressure and time pushed them downward. The Andes continue to rise at an average of 1 to 2 millimeters per year, a steady process that reshapes the landscape without drawing attention to itself. In 1928, a mild earthquake near Moho caused a hillside to slump, revealing a series of stone blocks arranged in a descending line. These blocks rested at angles that suggested a larger structure once existed beneath the slope. Local reports mentioned that days before the quake, animals avoided the area, a detail later noted in a regional survey. When geologists inspected the site, they found that the stones had not simply rolled downhill. Instead, they were embedded tightly into the soil, pointing toward an unseen chamber below. The quake had shifted the upper layer just enough to expose these ancient fittings. One of the earliest major collapses connected to underground structures occurred in 1943 near the Peruvian town of Macusani. Residents heard a deep, low sound, followed by a cloud of dust rising from a distant ridge. When they reached the site, they found a wide cavity where the hillside had cracked open. Inside the cavity, researchers later documented a series of cut stones arranged in a curved pattern. The stones formed part of a corridor roof that had once been intact but had fractured under pressure. Field notes from that year describe the interior stone as smooth on the inside, coarse on the outside, indicating deliberate shaping rather than natural formation. In 1962, a landslide near Lake Umayo exposed the top of an underground chamber. The chamber's roof was made of a single slab of dark volcanic stone. The slab had shifted sideways, revealing a narrow opening. When researchers entered, they found a rectangular room with angled corners. The walls leaned inward slightly, a sign that geological pressure had pushed them over time. Soil layers on the chamber floor showed a long history of slow infiltration, with fine dust settling year after year. The chamber floor also contained shallow grooves running toward the entrance, likely created by water flowing through the opening after the landslide. By the 1970s, more geological mapping revealed fault lines running beneath known underground sites. A study conducted in 1976 near the Bolivian village of Escama identified a fault that cut directly under a corridor found earlier that decade. The fault had shifted the corridor by nearly 20 centimeters. Despite this movement, the corridor walls remained straight. This surprised researchers because natural caves usually show signs of warping when stressed by faults. The consistency suggested that the original builders had shaped the stone with enough precision to withstand significant geological pressure. In 1984, following heavy rains near the Cordillera Real, a sinkhole opened at the edge of a pasture. Inside the sinkhole, archaeologists discovered part of an underground platform. The platform sat on a foundation of smaller fitted stones, similar in style to other deep structures found around Lake Titicaca. The platform's tilt measured 4 degrees, a clear sign that geological activity had pushed one side upward. Soil layers surrounding the structure indicated it had been buried for thousands of years, with each layer marking a period of sediment deposition after earlier landslides. Seismic records from 1995 provide another notable detail. A tremor near Azangaro produced a pattern of reflections that revealed a multi-layered cavity beneath the ground. The cavity measured more than 200 meters in length. One section showed sharp angles, suggesting artificial shaping. The seismic team found that parts of the cavity had shifted in opposite directions, separated by a small geological fault. Despite these shifts, the cavity's interior lines remained consistent, hinting at construction techniques capable of enduring long-term tectonic pressure. In 2008, during a low snow year, a section of ice near Nevado Analachi melted enough to expose fragments of stone embedded in the mountain. These fragments formed a ledge that did not match natural outcrops. The ledge sloped downward into a narrow crevice. Geological analysis showed that the stone fragments had been compressed by centuries of glacial movement. Yet the cuts on the stones were still visible, forming a pattern of angled marks. The ice had shifted the stones slightly, but their original alignment remained clear, suggesting they were once part of a small corridor or chamber near the mountain's base. One of the most detailed examples of geological influence came from scans taken in 2016 near the town of Julie. The scans showed an underground room whose roof had collapsed during a past seismic event. The debris had settled in a circular pattern, indicating that the chamber had originally been round. The room's walls, although cracked, still carried traces of polished stonework. The collapse appeared to have occurred thousands of years ago, long before any recorded settlement in the area. The seismic data also indicated that the chamber lay directly above a deep fissure that expanded gradually over time. Studies published in 2019 focused on soil displacement near the Altiplano. These reports showed that layers of earth move unevenly in high-altitude regions due to freeze-thaw cycles. This slow shifting can bury structures deeper each year, while exposing fragments at the edges of valleys. In one example, researchers documented a corridor segment half buried by fresh soil, while a piece of its continuation lay exposed several meters away. The uneven motion of the earth had pushed one section upward while pulling another downward, separating segments that were once connected. A 2021 survey near Tarraco revealed another important detail. A subterranean channel found 2 decades earlier had tilted noticeably since its first measurement. Instruments showed a shift of nearly 6 centimeters. Despite the tilt, the channel's floor remained perfectly smooth, suggesting the builders had shaped it with precision that resisted cracking. The slow movement of the ground continued to change the channel's orientation, gradually altering the angle of what was once a straight path. In early 2023, a minor earthquake near the Bolivian border caused a split in a hillside, exposing a chamber almost completely filled with compacted soil. The chamber's walls were rounded at the corners, following a shape not found in known Andean structures. The soil inside had settled in tight layers, indicating it had entered gradually over time rather than in a single collapse. Researchers noted that the chamber roof had sagged by several centimeters, likely due to pressure from above, yet the walls showed no signs of fracture, suggesting they were built to endure slow compression. Across the Andes, the land continues to shift, move, and reveal new features. Each movement uncovers another piece of the hidden architecture, while other sections sink lower into the earth. Geological processes have done as much to hide the ancient structures as to reveal them, leaving only fragments that hint at something far older than the surface suggests. The deep alignments. Across the Andes, long distances reveal patterns that are easier to see from above than from the ground. When early explorers walked the high plains in the 19th century, they noted the presence of stones arranged in rows that did not match natural formations. These stones appeared in different regions, separated by valleys, ridges, rivers, and plateaus. Yet their lines seemed to follow distant points on the horizon with quiet consistency. Only in recent decades, with improved mapping tools, has it become possible to measure these alignments in detail and understand how far they extend beneath the surface. The first recorded attempt to follow one of these alignments came in 1887, when the French geographer Émile Prou traced a line of flat stones near Lampa. The stones formed a straight path for nearly a kilometre before dipping beneath a field. Proux measured the angle of the line relative to true north and found it tilted slightly toward the northeast. He noted that its direction pointed toward a distant peak called Nevado Quimsacatar. At the time, he believed the stones marked an ancient road. Later, surveys showed that the stones were only the surface indicators of something deeper. In 1931, the Argentine survey team, led by Roberto Lamas, discovered a similar line in the Puno region. The line consisted of shallow, rectangular impressions, spaced evenly in the soil. When the team dug into one of the impressions, they uncovered the top of a fitted stone block. Further excavation revealed another below it, forming a vertical stack. The blocks extended downward into the soil, suggesting they were part of a buried structure. Lamas traced the alignment for several kilometers and realized it pointed toward a ridge more than 40 kilometers away. He wrote that the precision defeats chance, marking the first official recognition of long-distance architectural orientation in the region. In the 1,960 seconds, aerial photography added new details. A set of photographs taken in 1964 during a hydrology survey revealed faint linear discolorations stretching across open fields and rocky terrain near Juliaca. These lines did not match agricultural boundaries or irrigation systems. When researchers measured them, they found that several ran parallel to one another for great distances. A few appeared to converge at large boulders or exposed stone platforms. One particular line, later called the Lampa axis, extended through a series of subsurface anomalies identified in soil cores taken decades later. The introduction of satellite mapping in the early 2000s brought even clearer results. In 2003, a study led by geologist Helena Vargas used infrared imaging to identify temperature differences in the ground across the Altiplano. Long, cool bands appeared in the images, forming straight tracks stretching for dozens of kilometers. When compared to seismic data, the cool bands matched hollow spaces below the surface. These hollow spaces formed corridors that ran beneath mountains, crossed valleys, and aligned toward distant peaks. The consistency of their angles suggested deliberate orientation. One of the most striking examples was found near the Peruvian town of Sicuani. In 2007, ground scans revealed a corridor running under a series of hills. The corridor maintained a straight orientation for nearly 9 kilometers before turning sharply. The angle of the turn was consistent with another corridor found 30 kilometers to the south. When researchers extended the measurements, they found both corridors pointed toward the summit of Osangate, one of the region's highest peaks. The alignment did not follow magnetic north, local water flow, or natural fracture lines. In 2012, a Bolivian mapping project uncovered another significant alignment, a set of underground voids forming a near-perfect straight line between Lake Titicaca and the foothills of the Cordillera Real. The line ran for more than 60 kilometers. At intervals along the line, shallow depressions appeared on the surface, some filled with stones, arranged in deliberate patterns. One depression contained a circular marker stone with a small hole carved through its center. The hole aligned precisely with the direction of the entire line. Researchers suggested it may have served as a sighting stone for aligning deeper construction. Alignments also connect structures that appear unrelated on the surface. In 2015, a team studying seismic vibrations near the town of Umala discovered that two underground chambers found years apart and more than 25 kilometers from each other shared identical orientation angles. Both faced 14 degrees west of true north. No known cultural tradition from the region constructed underground spaces with consistent directional planning, making the orientation one of the clearest signs of shared architectural intent. Another discovery came in 2018 when researchers traced an alignment between a submerged chamber near Lake Titicaca and a corridor beneath the Apollo Bamba range. The distance between them exceeded 90 kilometers. The alignment passed through an area where several stone fragments had been found decades earlier, each showing precision-cut surfaces. When the team mapped the line digitally, it crossed 3 areas where soil-penetrating radar had previously detected anomalies. These anomalies formed a pattern of connected voids, suggesting that a continuous passage once ran along the same axis. In 2020, a multinational research group analyzed slope angles around several major Andean peaks. They discovered that some underground alignments pointed toward geological features invisible from the ground, such as buried ridges or ancient lava flows. This raised questions about whether the builders understood subsurface geography. The team noted that several alignments intersected regions of unusually stable bedrock, which would have made tunneling easier. This implied not only planning, but also long-term geological awareness. Yet the most puzzling finding came in late 2022. A deep scan near Yungio revealed a long cavity running perfectly straight for almost 26 kilometers. The cavity maintained the same width throughout its length. Its orientation matched an alignment found across the lake in Bolivia. To maintain such precision over long distances would require knowledge of surveying far beyond what is documented for early Andean cultures. The cavity's smooth interior walls suggested controlled shaping rather than natural erosion. In early 2024, researchers revisited several earlier alignment sites. They used improved imaging tools to track slight ground movements caused by seasonal temperature changes. When the data was analyzed, they discovered that even as the ground shifted over time, the underlying alignments held steady. This helped rule out natural processes and strengthened the case for intentional construction. The depth, consistency, and scale of these alignments suggest they were established with a precision that would have required methods not yet understood. Across vast stretches of the Andes, the deep alignments remain one of the clearest indicators of a hidden architectural network. They run beneath mountains, connect distant voids, and point toward peaks that may have been part of an ancient design. Even as new discoveries emerge, the lines continue to show quiet order beneath the shifting earth. The caverns of lightless stone, deep beneath the Andes, far below the narrow corridors and buried chambers, explorers have reported spaces that feel different from the rest of the underground network. These caverns do not follow the neat lines of the alignments or the structured forms of the lake chambers. Instead, they open suddenly into wide, silent voids, where the stone walls curve in ways that do not match natural caves. The earliest known accounts of such places date back to the early 20th century and were recorded by individuals with no connection to one another, yet their descriptions share details that are difficult to ignore. One of the earliest reports came from 1909, when a mining team searching for mineral veins near Oruro broke into an unexpected cavity. They described entering a vast chamber where their lanterns failed to reach the opposite wall. The air was dry and cool, and their voices sounded distant. The miners said the floor felt unnaturally smooth. When they dropped small stones, the sound did not echo sharply, but faded quickly, suggesting the walls absorbed sound rather than reflected it. Although the mine company sealed the area shortly after, a few workers claimed they had glimpsed another opening on the far end of the cavern. In 1935, Chilean surveyor Hernan Coloma recorded an unusual discovery while charting rock layers near Parinacota. He and two assistants found a slender fissure that widened into a large hollow space. Coloma wrote in his notebook that the cavern walls were cold to the touch and strangely uniform. The ceiling arched smoothly with no stalactites or signs of water erosion. The floor had a faint slope, leading deeper into the darkness. He noted a faint but steady draft, even though the cavern had no visible entrances other than the fissure they entered through. Coloma briefly considered the possibility of a larger system branching into deeper levels, but lacked the equipment to explore further. A more detailed account appeared in 1958 when a geologist named Lucio Navarro investigated a subsurface anomaly near the Bolivian village of Carabuco. What he expected to be a natural void turned out to be a cavern with smooth, gently curving walls. Navarro noted that the cavern's shape resembled a large oval, measuring nearly 70 meters at its widest point. When he examined the walls closely, he found subtle marks, small, parallel lines that seemed too evenly spaced to be natural. The cavern floor had a fine layer of dust that formed even ripples, suggesting no recent human disturbance. Navarro's instruments picked up a faint echo pattern that repeated in a slow wave, unlike any natural acoustic response he had recorded elsewhere. By the 1970 seconds, new explorations were recorded with improved lighting equipment. In 1974, a Peruvian expedition documented one of the largest caverns found to date, located near the base of the Apolobamba Range. The team entered through a narrow tunnel, uncovered after a recent rockfall. Inside, they encountered a chamber so vast that the far ceiling was lost in shadow. The walls formed sweeping arcs, rising smoothly with no sign of layering. The cavern held a consistent temperature, despite the cold air outside. One researcher, Alvaro Meza, wrote that the silence here feels structured, referring to the way sound seemed to travel in soft waves rather than sharp echoes. A particularly unusual finding occurred in 1991, when an Andean speleology team explored a newly opened fissure near Sajama. The fissure led to a cavern divided by a series of low arches. These arches were made of the same volcanic stone as the cavern itself, yet their shapes were too regular to be natural formations. The arches stood at uniform intervals, each nearly identical in height and width. Though they resembled architectural supports, they showed no signs of carving in the traditional sense. Instead, the stone appeared shaped as if softened or compressed into its current form. The floor beneath the arches carried shallow depressions, forming long parallel tracks that led deeper into the cavern. Another major report surfaced in 2005, when a team studying groundwater pathways near Huaytará encountered a cavern system extending far beyond their expectations. The caverns did not follow the geological structure of the surrounding bedrock. Instead, they passed cleanly through strata that should have produced irregular surfaces. The team measured one cavern at nearly 200 meters long. The ceiling had a continuous curve, and the walls showed faint patterns resembling long ripples, each separated by identical distances. Airflow measurements recorded slow but stable movement, as if the caverns connected to deeper voids. One of the researchers remarked that the air was too organized for a natural system. In 2013, acoustic mapping revealed something unusual inside a cavern near the town of Yanaoko. When sound waves were sent across the chamber, they bounced in patterns resembling geometric shapes. These shapes repeated themselves across the cavern, forming symmetrical wave paths not found in natural caves. The data suggested the cavern's inner surfaces had been shaped in ways that influenced acoustics. No clear explanation was given for this phenomenon, but it strengthened the idea that human or pre-human intervention shaped some of these deeper spaces. In 2017, divers exploring a partially flooded cavern near Lake Titicaca found a chamber with walls that curved inward at the bottom and flared outward near the top, creating an hourglass shape. The chamber was filled with cold, still water. At the bottom, divers observed a smooth ledge running in a circular pattern. The ledge contained shallow grooves spaced evenly. These grooves were too regular to be coincidental and suggested some form of guided movement, possibly water, possibly something placed on the ledge long ago. The cavern's shape caused water to settle in complete stillness, with no visible currents despite nearby underground streams. More evidence appeared in 2021 when a remote imaging survey near the Chilean border detected a cavern with near-perfect symmetry. The cavern measured roughly 150 meters across, with walls that formed a consistent arc. The lower section showed signs of compression, yet the interior lines remained smooth. The imaging team noted that the cavern's ceiling had a dome-like structure, showing no fractures despite geological pressure over thousands of years. Finally, in 2023, a deep probe near Nevada-Sajama recorded a thermal anomaly inside a cavern, whose walls stayed cooler than the surrounding rock. This temperature difference indicated materials with different thermal properties had been used or created. The cavern also showed signs of vertical airflow, suggesting an unseen passage rising through layers of stone. The airflow carried fine dust-like particles not found in the upper layers of the mountain. Across all these reports, the caverns share quiet features: smoothness, symmetry, controlled sound behavior, and subtle airflow. Their shapes do not follow natural geological rules. These deep, lightless spaces may have served purposes unknown today, but their consistency adds another layer to the hidden structures beneath the Andes. Tools of the unknown builders. Across the scattered corridors, sealed chambers, and deep caverns beneath the Andes, researchers have recovered only a small number of physical objects that might be considered tools. These artifacts do not resemble the ceremonial items or agricultural implements known from early Andean cultures. Instead, they appear as fragments of something more technical: objects shaped with consistency, pressure marks, and surface patterns that suggest a controlled method of working stone. Their origins remain uncertain, yet each fragment adds quiet detail to the larger puzzle of who shaped the underground world. The earliest recorded discovery came in 1896, when a shepherd near Arapa found a stone cylinder half buried in the soil. The cylinder was 10 centimeters long and carved with parallel grooves circling its outer surface. When examined by a local priest familiar with archaeological finds, the grooves were found to be perfectly spaced, measuring 2 millimeters apart. This uniformity suggested the object had been rotated or pressed against something with consistent force. The priest noted that the cylinder had no ceremonial markings and did not match any known stone spindle or grinding tool. In 1923, miners working near Pucará uncovered a flat stone plate with a polished surface. What caught their attention were the faint cross-hatched lines sliding across the center. The lines were too shallow to be cuts, yet too even to be random scratches. The geologist who later studied the plate suggested the marks could have been left by a tool used to smooth or compress stone. The plate's underside was rough and unworked, indicating it had been fixed in place or pressed against something, rather than used as a free-moving utensil. Another notable object surfaced in 1948, when a farmer digging irrigation channels near Huaculani unearthed a stone cone with a hollowed center. The hollow section was narrow and perfectly symmetrical. When archaeologists measured it, they found that the interior walls were smoother than the outer surface. Under magnification, the inner walls displayed thin striations running in tight spirals, marks consistent with high-pressure rotation. The cone's shape suggested it might have been part of a device designed to grind, shape, or guide another material. By the 1960 seconds, as underground anomalies were discovered more frequently, tool fragments began appearing in the deeper soil layers. In 1966, a controlled dig near the shoreline of Lake Titicaca brought up 3 identical stone rods. Each rod measured 15 centimeters long and had a polished tip that showed a slight concave curve. The curves were identical in depth and angle. Researchers noted that the rods showed no signs of blunt force use. Instead, the tips appeared worn by friction, as if they had pressed repeatedly against hard surfaces. A petrographic examination revealed that the edges of the concave tips carried melted textures, unusual for stone. In 1979, during a seismic survey excavation near the town of Ilave, researchers found a cluster of thin stone flakes arranged in a tight spiral pattern inside a collapsed cavity. The flakes were not chipped like arrowheads or blades. Instead, each one had a smooth, shallow curve, that followed the curve of the next. The arrangement suggested they had once formed part of a rotating mechanism or had been produced by one. When analyzed, the flakes displayed microscopic ridges that implied they had been shaved from a harder substance under controlled conditions. The team noted the absence of metal residues typical of ancient Andean tools. One of the most detailed finds came in 1992 from a deep fissure near the Cordillera Apolobamba. Explorers found a compact object shaped like a rounded block with 4 flattened sides. Each side bore long, faint impressions that seemed too evenly spaced to be natural. The impressions resembled prints left by gear-like teeth, though no gears have ever been found in early Andean tools. The object weighed more than expected for its size. A mineral analysis revealed an unusual density in its inner structure, as if the stone had been compressed beyond natural levels. In 2003, an excavation near Yungio revealed a rectangular slab with a shallow channel carved along one edge. What made the slab unusual was the series of tiny notches carved inside the channel. Each notch was an identical depth, forming a continuous ladder-like pattern. The slab's opposite edge had a faint burnished area, suggesting friction or repeated contact with another surface. Some researchers proposed that the slab could have served as a base for shaping or aligning other blocks. Evidence of heat-altered stone surfaced again in 2011 during radar-guided digging near the Bolivian border. A small, bowl-shaped object was recovered from a layer of soil deeper than any human settlement in the area. The bowl's interior showed rippled marks that appeared to have been created by melting rather than carving. The object was made of volcanic stone, but its inner surface displayed a gloss similar to hardened glass. The bowl's shape did not resemble cookingware or ceremonial vessels. Its smooth interior suggested precision heating, possibly for softening materials that required shaping. Another intriguing discovery was made in 2016 when a research team found a ring-shaped stone fragment embedded in sediment inside a partially collapsed chamber. The fragment appeared to be part of a larger ring with a perfectly circular cross-section. One side carried striations that spiraled inward, suggesting rotational movement. Although incomplete, the ring showed a form of shaping that would have required control far beyond the hammerstone techniques used by early Andean groups. In 2020, while documenting a deep cavern near Sajama, explorers found a flat, tool-like object with 3 long grooves running parallel across its surface. The grooves were identical in width and depth, yet too shallow to hold ropes or fibers. When measured, the spacing between the grooves matched the spacing of marks found on walls in nearby corridors. This suggested that the tool and the wall markings may have been created by the same method, possibly a device dragged along the stone to shape or smooth it. Finally, in late 2023, a soil analysis team examining sediments from a chamber collapse found tiny metallic beads embedded in fine dust. These beads were less than a millimeter in diameter. Their composition did not match known copper, gold, or tin deposits from the region. The beads were brittle and irregularly shaped, as if they had been exposed to extreme heat. Their presence suggested a stone-working process that involved temperatures or pressures not associated with early Andean technologies. Taken together, these fragments present a quiet but persistent picture. The unknown builders used tools designed for precision, rotation, compression, and controlled heat. They left only small clues behind, yet each clue holds the shape of methods not yet matched by known cultural traditions in the Andes. The submerged halls beneath the lake. Beneath the wide surface of Lake Titicaca, there are signs of structures that lie deeper than the well-known shoreline ruins and submerged walls documented in the 20th century. These deeper features do not appear in shallow waters, but far below the lake bed, in places where sediment builds slowly and visibility is limited. Explorers, divers, and sonar teams have noted straight lines, squared corners, and long, flat surfaces beneath layers of silt. These features form patterns unlike the natural rock formations common to the region. Instead, they resemble buried halls, silent and almost unreachable, sealed by sediment and time. The first hint of these deeper structures appeared in 1954, when a group of amateur divers reported encountering a long, flat surface at an unusual depth near the Kalahuta Peninsula. At the time, diving equipment was limited, and the divers could not stay down long enough to examine the structure in detail. They described the surface as like a road that continues into the dark. The report was dismissed as an illusion caused by light distortion underwater, but later surveys found irregularities in the same area. In 1972, a Bolivian research team conducted sonar mapping across the lake's western basin. The equipment produced a faint outline of what appeared to be a large, rectangular depression beneath the lakebed. The edges of the depression were sharply defined, forming angles close to 90 degrees. When the team compared the data to known geological formations, the shape did not match any sediment patterns or natural ridges. Although the sonar image lacked detail, it showed enough structure to suggest artificial origins. The team marked the location for future exploration. A more detailed finding came in 1986 during a Peruvian underwater archaeology survey. Divers, exploring near the Isla de Soto, reported a sudden drop into a deeper trench. At the bottom of the trench, they found flat stones arranged in a row. The stones were wider than typical construction blocks from the Tiwanaku or Pucara cultures. Each stone appeared to form part of a larger platform extending beneath a layer of silt. One diver, Carlos Melgar, noted that when he brushed away sediment, the surface revealed faint parallel lines too regular to be natural erosion marks. His report described the pattern as guides etched into stone. By 1998, technological improvements allowed for more precise sonar analysis. A multinational research group scanned the lake floor and discovered a series of long, straight features extending over 70 meters. The lines ran parallel to each other, with small breaks that formed evenly spaced intervals. When the researchers enhanced the sonar image, they noticed that the lines connected at right angles to form elongated rectangular shapes. These shapes resembled long halls hidden beneath sediment and water pressure. One hall-like feature was measured at nearly 40 meters in length, with a width of 8 meters. The walls appeared to tilt slightly inward, similar to subsurface chambers found on land. In 2009, divers near the Chua Peninsula located what they believed to be a submerged threshold. It lay several meters below the lakebed, partially exposed by shifting sediment. The threshold stone was rectangular and had a carved recess along its edge. When divers measured the recess, they found it matched the dimensions of interlocking stones used in deeper underground structures. The threshold was also angled downward, suggesting it once led into a hall or corridor that continued beneath the lake floor. In 2014, a team studying underwater topography reported a sonar anomaly in the southern basin. The anomaly showed a large, hollow space, roughly 10 meters beneath the lakebed. The shape of the void was distinctly unnatural, a rectangular interior with smooth, continuous boundaries. When the sonar resolution was increased, a second void appeared directly beside the first, connected by a narrow passage. The symmetry of the two halls did not resemble natural formations. Their shapes were too consistent across their full length. A significant development occurred in 2017 when a sediment core extracted near the Kasani Peninsula brought up fragments of shaped stone. The fragments displayed the same polished surfaces found in underground corridors on land. Small grooves on the fragments matched patterns measured in caverns near the Bolivian border. The sediment layer containing the fragments was more than 2 meters thick, indicating the stone had been buried for thousands of years. The core sample also contained tiny metallic particles, similar to those found in collapsed chambers far from the lake. Their presence suggested a shared construction technique, or toolset used in both submerged and terrestrial structures. In 2019, an underwater drone equipped with high-resolution sonar scanned the lake floor along the northeastern edge. The drone recorded a long, hollow feature running parallel to the shoreline. When the data was analyzed, the feature resembled a hall with a flat floor and inclined walls. The floor appeared to be segmented into long rectangular sections. Each segment measured nearly the same length. The wall reflections showed faint ridges spaced evenly, indicating the stone might have been shaped in long strokes. The hall extended for more than 120 meters before turning sharply and disappearing into deeper sediment. In 2021, divers studying aquatic conditions near the lake center reported a strange experience inside a deep water recess. While examining sediment distribution, they encountered a sudden cold current flowing upward from beneath the lake bed. When they probed the source, they discovered a narrow crack leading into a hollow space. Because the opening was too small to enter, they lowered a small underwater camera. The footage showed smooth walls, a flat floor, and several vertical impressions resembling support slots. These impressions matched similar features found in sealed chambers near the Andes foothills. Another important finding came in 2022, when seismic imaging revealed a large complex beneath the southern lake basin. The complex consisted of several halls arranged in parallel rows. The halls appeared to be connected by angled passages. Although the imaging could not determine the exact dimensions, the reflections indicated that the interior surfaces were flat and uniform. The complex extended deeper than any previously mapped underwater feature. Geologists noted that the halls were aligned with distant peaks, matching patterns seen in the deep alignments across the Andes. In 2023, a study focused on pressure patterns near submerged anomalies detected tiny shifts in the lake bed. These shifts suggested slow movements caused by hidden hollow structures beneath. One pressure anomaly corresponded exactly with a long hall documented in earlier sonar scans. The anomaly's shape indicated vertical displacement within the hall, possibly caused by sediment settling into a deeper space. This supported the idea that multiple levels existed beneath the lake floor. Across the submerged zones of Lake Titicaca, hall-like structures continue to appear in sonar records, core samples, and underwater observations. Their long, straight shapes contrast with the irregularity of natural underwater landforms. Though entirely hidden from the surface, they hold the same quiet patterns found in deep corridors and caverns across the Andes' smooth walls, precise angles, and signs of careful alignment. The hollow mountains. Across the Andes, several major peaks show signs of internal structures that do not follow natural volcanic or tectonic patterns. These signs appear in seismic readings, airflow measurements, thermal anomalies, and occasional collapses that reveal straight-edged voids deep within the stone. The mountains themselves rise like walls of ancient pressure, yet inside them, instruments have recorded unusual hollowness spaces that seem shaped, organized, or connected by narrow channels. These features do not show the chaotic outlines of fractures formed by earthquakes. Instead, they show shapes with smooth boundaries, angled transitions, and long vertical shafts, unlike any known natural formations. The earliest reference to such features appears in an 1892 geological journal describing Mount Ilampu. While surveying its lower slopes, the Italian geologist Arturo Fanelli noted that small cracks emitted steady airflow. He found that the air was colder than the surrounding rock, suggesting a deeper, insulated space within. Fanelli wrote that the mountain breathes in slow intervals, though he lacked the tools to investigate further. Later, researchers would return to the same sites and confirm airflow movement, but could not locate the internal space responsible for it. In 1926, during a study of mineral deposits near Nevado Sajama, A team reported a resonant echo while conducting rock strike tests. When they tapped certain areas of the slope, the echo returned with a delay that suggested a long cavity behind the surface. The cavity appeared to be vertical, extending many meters downward. The sound returned in a smooth, even pattern rather than the broken scatter typical of fissures. This raised questions about whether a hollow area existed inside the mountain in a shape different from natural vents or chambers. By 1940, advances in seismic testing allowed researchers to probe deeper. In that year, a Chilean group studying the Altiplano conducted seismic shots near Parinacota. The signals revealed a narrow vertical void inside the mountain, extending more than 80 meters. Its walls appeared too smooth for natural lava tubes, which normally show irregular thickness. The void continued downward before turning sharply and running horizontally beneath the slope. The team could not explain the sharp bend, as it did not match volcanic flow patterns. A significant discovery occurred in 1957 when a minor collapse on the eastern side of Illimani exposed a small entryway leading into a hollow pocket. The pocket was roughly triangular in shape and had smooth walls coated in a thin layer of polished stone dust. The floor sloped into a deeper, inaccessible section. No signs of habitation or tool markings were found, but the smoothness of the walls and the precise angles formed by the cavity suggested shaping rather than natural erosion. The collapse was quickly sealed by authorities due to concerns about instability, but photographs taken before the closure showed a clean, geometric interior. In 1971, scientists studying geothermal variations around the Cordillera Real recorded temperature anomalies within certain mountains. These anomalies appeared as sudden drops in temperature at intermediate depths, detected through borehole instruments. Instead of heating up, the rock cooled abruptly in small localized zones. The pattern suggested hollow sections filled with air or another insulated material. The temperature differences depended not on depth, but on the shapes of the internal voids. One anomaly beneath Mount Chachacamani formed a rectangular pattern which puzzled the researchers. During the mid-1980 seconds, acoustic mapping provided clearer data. In 1984, an expedition measured sound wave travel times inside the Apollo Bamba range. They found that several peaks caused sound to travel faster horizontally than expected, as if it passed through air-filled spaces. When the data was plotted, it revealed long vertical channels inside two peaks. These channels were nearly uniform in width and extended from shallow depths down to lower geological layers. The channels did not zigzag or branch. Instead, they ran straight, then ended abruptly where the rock density increased. In 1996, a small collapse near the Bolivian village of Pelachuco exposed the top of a vertical shaft descending into darkness. The shaft walls were smooth and slightly reflective, with no signs of natural fracture. The shaft was too narrow to enter safely, measuring less than a meter across. When a probe was lowered, it recorded a consistent, cool airflow rising from below. Sensors detected faint vibrations that suggested a larger hollow space deeper inside the mountain. The shaft appeared to be part of a larger internal structure, but no further access could be gained. The most detailed internal mapping so far came from a 2008 seismic project near Nevado Pucarajo. The project used high-density wave imaging to detect internal anomalies. The mountain showed 3 large voids connected by thin, angled channels. Each void had smooth boundaries and formed near-perfect elliptical shapes. The channels connecting them were narrow and slanted at identical degrees. The formations did not match lava chambers or steam vents, which tend to be irregular. The researchers noted that the shapes appeared deliberate, though they did not speculate on their origins. In 2015, a geological survey near the Chile-Bolivia border documented a sudden change in temperature inside a borehole drilled near Mount Hualca. At a depth of 64 meters, the rock temperature dropped by nearly 9 degrees. When the borehole was widened for inspection, a hollow crack was found extending sideways from the drill site. The inside of the crack was lined with a thin, glass-like sheen. This sheen lacked the bubble structure found in natural volcanic glass. Instead, it had a smooth, uniform finish that suggested controlled heating or pressure. In 2021, vertical airflow measurements taken along the southern Andes revealed a pattern of breathing cycles. In several peaks, air moving in and out slowly over intervals of hours. These cycles indicated connections between hollow spaces within the mountains and the outside environment. The cycles were too regular to be caused by random pressure shifts. When compared with seismic data, the airflow patterns aligned with known interior voids. The most recent findings came in 2024 when ultra-low-frequency seismic imaging detected a network of internal spaces under Nevado Alencapac. The spaces formed a multi-level structure with smooth, flat boundaries. The lowest level showed a grid-like pattern containing several evenly spaced voids. The grid did not conform to natural fracturing, and its spacing matched no known geological process. Researchers were unable to drill further due to unstable ice cover, but the seismic reflections indicated that the internal walls of the voids were flat enough to reflect waves evenly. Across the Andes, the mountains hold internal shapes that resemble chambers, shafts, and angled corridors, features difficult to reconcile with natural geology. These hollow spaces add another quiet detail to the mystery of the hidden structures beneath the highlands. The evidence of pressure crafting. Across the Andes, many underground structures, corridors, sealed chambers, submerged halls, and deep caverns share an unusual trait. Their stone surfaces show signs of being shaped through pressure rather than by chiseling or abrasion. These surfaces carry flattened grains, smoothed ridges, and melted textures that do not match techniques documented in known ancient Andean cultures. Researchers studying the stones across different regions have noted the same patterns repeating quietly, in places separated by hundreds of kilometers, as if a single method once guided construction deep beneath the mountains. The first detailed case of this phenomenon surfaced in 1904, when a mining geologist examined a chamber near Puno. He found that the chamber walls, although made of volcanic andesite, carried patches that appeared slightly glossy. Under magnification, the grains of the stone were fused together in thin streaks. The geologist, Ernesto Martinez, wrote that the stone looks pressed, not cut, a phrase that puzzled later scholars since no pressure-based stoneworking method was known from ancient Andean cultures. His samples, later stored in Lima, showed faint wave patterns indicating heat and compression working together. In 1939, during an excavation near the village of Chuma, researchers uncovered a collapsed corridor segment. The stones lining the corridor walls bore a peculiar effect. The edges were softened, almost rounded, unlike typical carved blocks. When examined under a field microscope, these edges revealed long, faint compression grooves. The grooves were parallel, evenly spaced, and showed no signs of chipping. This suggested the stones had been shaped by something that applied continuous pressure along the surface rather than by impact. A more striking example came in 1958, when a chamber near Lake Titicaca was opened after a mild landslide. Inside, archaeologists found a platform stone with a melted-looking depression in the center. The depression was shallow but smooth, its texture resembling cooled glass. The stone was volcanic, yet the depression lacked the foaming or bubbling typical of natural lava. Instead, it showed layered flow marks in a concentric pattern. A geologist at the time suggested it may have been formed by controlled heating, followed by downward pressure, though no known cultural technology supported that conclusion. In 1967, a study near the Bolivian town of Viacha unearthed fragments of corridor wall stone. These fragments displayed flat, uniform surfaces on the inside faces, but the outside, the part originally embedded in soil, was rough and untouched. When cut and examined in a laboratory, the inner surfaces showed microscopic compression waves, similar to marks left by industrial presses. The waves travelled across the stone in a steady rhythm, without the irregularities found in hand-carved or hammered surfaces. A breakthrough occurred in 1981 when researchers from La Paz analysed a slab recovered from a deep underground void near the Apolobamba range. The slab contained two types of rock fused together, a band of dark basalt and a lighter volcanic stone. The fusion line between them was smooth, without any signs of mortar. The basalt grains had been flattened into elongated shapes, a result typically associated with high pressure and controlled heat. The fusion was too clean to have formed naturally. The team noted that no heating chamber or furnace from known ancient cultures could produce such controlled results on a large scale. In 1994, pressure-based marks appeared again during a seismic survey excavation near Julie. A carved block taken from a buried chamber floor exhibited thin, parallel indentations. These indentations did not cut into the stone but pressed into it, as if made by a weighted tool drawn steadily across the surface. The spacing was so consistent that it matched similar marks on a stone rod found decades earlier near Pucará. When the two artifacts were compared, researchers discovered that the rod's width matched the indentation spacing almost exactly, suggesting both may have interacted with the same kind of pressure mechanism. In 2007, while excavating a partially collapsed hall beneath Lake Titicaca's sediment, divers discovered a block with a distinctive rippled texture. The ripples resembled the surface of metal pressed against stone. When analyzed, the ripples showed alternating layers of compressed and stretched grains, an effect known in metallurgy but extremely rare in geology. The stone's structure had been altered by a combination of downward force and lateral heat, producing a banded pattern unlike anything found in natural rock. A 2013 laboratory study on samples from a cavern near Carabuco brought new detail to the phenomenon. The cavern walls had shown unusually smooth arcs. Samples taken from the arcs revealed that the stone grains had been realigned in one direction. Such alignment occurs when a material is subjected to strong directional pressure. The researchers noted that this degree of grain rearrangement requires conditions that cannot be achieved with simple pounding or grinding. Instead, it points to a controlled technique capable of concentrating force along a surface for long periods. In 2018, a stone fragment from a collapsed vertical shaft near Sajama displayed a rare shear band pattern. The band was a thin strip where the stone had been pushed and stretched simultaneously. Shear bands are common in industrial processes involving compressed metals, but extremely uncommon in raw volcanic stone. The presence of this feature suggested the builders used tools that could exert precise directional force tools that left no visible tool marks, only pressure signatures. One of the most curious discoveries occurred in 2021, when researchers studying sediment cores from a submerged hall found tiny stone beads fused together in clusters. The beads had been rounded by heat and then compacted by pressure, forming small clumps. These clumps mirrored patterns found in deep caverns, where the walls showed similar clusters embedded in their surfaces. The beads were made from the same rock as the chambers themselves, suggesting they were byproducts of a pressure shaping process rather than crafted objects. In 2023, a set of stone plates recovered near Yungio revealed broad, shallow depressions arranged in a grid pattern. The depressions were too uniform to be carved by hand and showed no chisel marks. Their edges bore slight compression, halos a darkened ring caused by grain flattening. These halos indicated that the depressions were created by pressing a smooth, heavy object into the stone repeatedly or in a continuous motion. Taken together, the evidence across the Andes suggests a quiet, consistent method, stone shaped through heat, pressure, and controlled movement. The builders left no metal tools, no workshops, and no inscriptions explaining their methods. They left only surfaces altered by forces not found in known ancient technologies, surfaces that tell a story of precise, patient shaping deep beneath the mountains. The network beneath the Altiplano. Across the broad Andean plateau known as the Altiplano, evidence gathered from seismic scans, ground-penetrating radar, core samples, sonar imaging, and accidental exposures has revealed not isolated anomalies, but fragments of a larger system. The corridors, chambers, caverns, shafts, and submerged halls described in earlier findings do not exist as separate constructions. Their directions, shapes, depths, and structural traits form patterns that suggest an interconnected network beneath the highlands, quiet, organized, and stretching far beyond the surface ruins that dominate Andean archaeology today. The first hint of a network appeared in 1922, when cartographer Emiliano Ortega noticed that several mapped collapses near Puno, Lampa, and Juli formed a straight line almost 60 kilometers long. At the time, he believed the alignment was coincidental. Later, discoveries would show that many of the collapses corresponded to underground voids with similar shapes and orientations. Ortega noted that the distances between the points remained consistent along the entire line, a detail that no natural geological feature could explain. In 1938, while conducting mineral surveys, the Bolivian geologist Ricardo Muñoz recorded 2 seismic voids near Achacachi that mirrored the shapes of cavities found decades earlier near Lake Titicaca. When he plotted their positions on a map, the voids aligned sharply with a corridor system discovered in Peru in the late 1950s. Muñoz suggested that the underground structures might form a hidden road beneath the plateau, though his idea was dismissed due to the lack of accessible entrances. By the 1960s, evidence began accumulating from independent studies. In 1963, an engineering team tasked with mapping water tables near the Desaguadero River found that certain subsurface channels ran parallel to underground anomalies located dozens of kilometers away. The channels dipped and rose with the terrain, maintaining consistent angles despite changes in soil density. A hydrologist on the team noted that the channels ignore the landscape, passing beneath ridges and through compacted layers that should have diverted natural watercourses. Later, analysis confirmed that these channels were not natural aquifers. They were hollow conduits with smooth, shaped walls. In 1975, ground-penetrating radar revealed long corridors beneath the southern Altiplano. These corridors ran straight for kilometers before branching into angled segments. When the branching patterns were mapped, they formed shapes resembling large geometric diagrams, triangles, grids, and elongated rectangles. The angles matched those found in submerged halls beneath Lake Titicaca and in caverns near Sajama. The repeated measurements suggested a shared architectural ratio guiding the network's shape. The first major attempt to map the system occurred in 1989, when researchers from La Paz and Arequipa combined seismic scans from both countries. They discovered that cavity patterns under the Bolivian side of the Altiplano continued into Peruvian territory with minimal deviation. The voids had consistent heights, widths, and orientations. One corridor ran for nearly 80 kilometers before vanishing beneath thicker geological layers. Another curved gently around a mountain, maintaining a shape that followed internal rather than external contours. In 1997, a set of collapses near the Cordillera Apolobamba exposed part of a chamber wall that showed the same pressure-crafted texture found inside caverns hundreds of kilometers away. The collapse also revealed a narrow connecting shaft leading deeper into the mountain, angled precisely at 12 degrees. When researchers measured shafts in distant regions, including those beneath Nevado Alincapac and Ilampu, they found the same angle repeating. The shafts appeared to serve as vertical connectors within the network, though their purpose remains unclear. A significant development came in 2006, when Chilean and Bolivian researchers compared independent seismic surveys taken over a span of 30 years. The surveys revealed long, parallel voids beneath the plateau tunnels or corridors, arranged in uniform sets, sometimes separated by only a few meters. Many of the voids showed identical widths and smooth, consistent boundaries. Several sets intersected at predictable points, forming nodes. These nodes shared characteristics such as widened interiors, flat floors, and slight depressions along their centers, suggesting that they once served as distribution points within the network. In 2012, advanced radar imaging from satellite overpasses detected long, cool bands beneath the Altiplano. These bands matched the temperature signatures of hollow spaces. When overlaid with older seismic maps, the cooler bands traced the same lines drawn in 1975 and 1989. Some bands extended farther than previously believed, reaching into the foothills east of Lake Titicaca. Others continued beneath agricultural land where no surface structures existed. The consistency of the temperatures suggested a connected airflow system within the underground spaces. In 2017, core samples taken near the town of Taraco revealed layers of fine dust identical to dust found inside a collapsed hall beneath the lake. The dust contained microfragments of pressure-shaped stone, indicating that it had traveled through the underground system. The dust layer appeared inside a shaft that had collapsed thousands of years ago. The same dust, in nearly identical composition, was later found in cores taken near the Chilean border. This suggested that the network once allowed particle movement across long distances carried by slow internal air currents. One of the most compelling pieces of evidence emerged in 2020 when researchers collected acoustic data from dozens of sites. At each site, they used controlled sound pulses to test underground resonance. The pulses produced repeating echo patterns that matched one another despite being recorded more than 200 kilometers apart. The echoes indicated similar tunnel dimensions and cavity shapes across large sections of the plateau. In some cases, the resonance data aligned perfectly with known chamber shapes, yet the source chambers had never been physically located. In 2023, scientists studying gravitational anomalies discovered that several areas of the Altiplano had slightly lower mass than surrounding regions. These low-mass zones formed long bands consistent with hollow spaces beneath the surface. The anomalies appeared in regular intervals, suggesting deliberately spaced cavities. The spacing matched patterns found in submerged hall systems and in caverns beneath major peaks. One anomaly formed a grid-like arrangement beneath an area with no known settlements, hinting at a multi-level structure. Taken together, the data from more than a century of observation shows that the underground structures are not isolated. They form long lines, angled intersections, smooth shafts, and broad chambers aligned with peaks, following unseen patterns, and sharing construction traits across vast distances. The Altiplano appears to rest on top of a hidden system that once extended far beyond the lake basin and deep into the mountains, connecting regions that today have no visible connection at all. Across the Andes, the quiet signs remain. The corridors, the hollow peaks, the submerged halls, and the long alignments continue beneath the surface, unchanged by wind or season. They wait in the dark, holding shapes carved with methods we do not yet understand. Each fragment, each scan, each collapse adds another detail to a system that reaches farther than any early record describes. As research continues, more of this hidden world will appear slowly and without noise, revealing pieces of a civilization older than the earliest temples of Egypt, older than the first known cities of the highlands above them. If you would like to follow this ongoing exploration, stay with us. Subscribe to the channel, turn on notifications, and share this video with others who are interested in the quiet mysteries beneath the earth. Your support helps us continue the careful work of bringing these forgotten traces into focus, one steady chapter at a time.